Dr. Peter Lee has had an extremely distinguished career. He unified the theme that we've seen so far this morning, a lot of distinguished people coming from University of Michigan, where he got his PhD. He then went on to Carnegie Mellon, where he was there for over 20 years, including being department chair there. He then went and worked for Advanced Research Project Agency, ARPA, for a couple of years before then joining Microsoft. And he's worn many hats there as corporate vice president and as head of Microsoft Research, but I'll spare you those details, and maybe he won't. Instead, let me tell you how interesting I find his approach as an engineer to life, his own life, and to healthcare and AI. I invited him, this is probably the first time I met him in person, I invited him maybe 3 years ago to a salon that I host every month on entrepreneurship for Harvard University students at the medical school. And he gave a really good view of his career, but it essentially added up to failure after failure after failure and what he had learned from those failures. And I thought that was a fascinating way to think about life, because it's hard to learn from your successes because maybe there's many other ways to succeed. But failures, you can actually perhaps find something that you can modify. Further, when we had our first online symposium of this meeting because of COVID, it was online, Dr. Peter Lee talked about all the failures he had experienced in trying to bring AI to public health and clinical care for the pandemic, which I thought was a very, very useful way to think about how to build for the future. And so therefore, I was particularly first intrigued and then shocked when I had my first conversation with Peter back in last fall about a topic that he seemed to have almost no reservations, complete enthusiasm, in fact, dumbfoundedness about its performance, which was what we now know to be GPT-4. And it was the fact that someone who I'd viewed as a collector of failures, now with sudden enthusiasm, that allowed me to take that space to actually consider whether I wanted to share that enthusiasm, which I did, which has led us to have several interesting experiences, including with our friend and colleague, Carrie Goldberg, write a book. But I think it'd be much more interesting to hear from Peter Lee about his journey, so I'll stop there and thank Peter for joining us.
Well, I hope this isn't the next failure, but I guess time will tell. Let's see, is there a clicker on the podium?
Failure number one.
Failure number one. So just to, while I'm getting set up here, thank you very much. As Zach mentioned, late last summer, I was asked to take on an assignment. OpenAI had been developing what is now known as GPT-4. At that time, it was codenamed DaVinci 3. And with Microsoft's help, was really just very focused on trying to understand the system and steer it and get it to be well-behaved and so on. And so one question was, in some key areas of possible human benefit, like education and medicine, what are the implications? And so I took on the part of the project having to do with medicine. And I started off being extremely skeptical about the possibilities. But after, I would say about 3 weeks, I started to realize that something very important was happening. And then I also started to realize that I needed help because my medical knowledge just really wasn't up to snuff. And I reached out to Zach and I think Zach's first reaction was also skepticism, and then getting into what I would call sort of ordinary thinking about the possibilities of machine learning and AI in healthcare, and then he, as he describes himself, started to thrash because as he got deeper and deeper into what was happening, it became clear that something that we didn't fully grasp was going on and something potentially important. So I'd like to just very quickly run through those and then talk about some caveats and current state of knowledge. But the overall goal is to motivate all of you to really take this emerging new technology as seriously as possible, because my ultimate hope is that the medical community will take very assertive control and ownership of the questions of whether, when, and how this type of technology should be used in the delivery of healthcare, in medical research, and really in all aspects of human health. All right, so if you go back to last July or August, whenever I got started, and the very first question is, does this thing know anything about medicine? And maybe the oldest idea in the book, of course it's a very new book, is to try to have it solve problems in a medical examination, like the U.S. medical licensing exam. And so here's a representative example. This one about a 12-year-old girl, and then you see some results of a urinalysis, multiple choice. And maybe as we sit here today, not surprisingly, GPT-4 is able to answer the question correctly. What's a little bit more surprising, however, is that when asked for an explanation, it's able to explain its reasoning. And that reasoning shows signs, at least in the verbiage it's using, of causal inferences. It's using words like because, of counterfactual reasoning, and also reasons to eliminate the choices in the multiple choice exam that it didn't choose. And so for a computer scientist or a cognitive scientist, there's an immediate question: what's going on here? Is it actually reasoning in some way? As things have gone on further, we discover that, in fact, this thing seems to be very good at this sort of rote medical knowledge. I think a very good paper jointly by Microsoft and by Stanford University on the capabilities of GPT-4 in medical challenge problems, I think is worth a read. And in particular, they did a very careful job of really understanding that the problems that were presented to GPT-4 would not be present in the training set for GPT-4. And so they did a very careful construction of the challenge test and problem. And they find that in that circumstance, GPT-4 gets over 88% of the problems right. And so it does extremely well. And in every case is able to give an explanation for its reasoning. And this has sort of extended beyond that type of problem. The Stanford Human AI Institute had a very interesting paper also about a curbside consultation kinds of questions. And now here I thought it was extremely interesting. They find that GPT-4 is able to answer these curbside consult questions 93% of the time correctly. But what's more interesting is that the panel of clinicians that were assessing the correctness of GPT-4, they were unable to assess 27% of the problems. So they had to go outside and consult with others in order to do a full assessment. And I'll make reference to this UCSD Johns Hopkins paper about responses to patient questions. But again, over and over again, we're seeing more and more studies showing just the sheer kind of ability of the system to answer these types of medical questions. And something I'll return to a little later, but is extremely important, is that GPT-4 has had no specialized medical training. It has not been fine-tuned. And in fact, the GPT program itself has really been geared to the acquisition of general cognitive intelligence. And in fact, what we have found, we have rising suspicion that specialized fine-tuning too early actually impedes the acquisition of that general cognitive intelligence. And so far, that's been completely avoided. And despite that, it still does extremely well on these kinds of problems. I want to just emphasize, because there's sometimes some confusion, there is, if you go to chat.openai.com, the folks at OpenAI who've just been amazing throughout this whole effort have released for free something called ChatGPT, and that free version uses a model called GPT 3.5. But it's very important, I think, to understand that what I'm presenting here is actually based on a much, much more powerful model called GPT-4. And you can get access to GPT-4 if you buy a subscription from OpenAI for ChatGPT Plus, or you can use GPT-4 for free if you use the Bing search engine. And I personally would not trust GPT 3.5 or any other language model for my own personal health advice, but GPT-4, I think, is a different beast. Different people have different opinions about that, but that's how I see it. If you want to understand more about why GPT-4 is special, there is the original tech report from OpenAI. And then from Microsoft Research, we published something or posted something called the Sparks of AGI paper. It's a very long paper, unfortunately, 154 pages, but it's a fairly easy read because it's just many examples that separate the capabilities of GPT-4 from really all other known language models. Okay, so now beyond medical knowledge, what goes on? Well, if we take that US medical license exam problem, we can ask questions that really speak to some acquisition of theory of mind. We can ask, what do you think the girl describing this problem might be thinking and feeling? And GPT-4 will make a disclaimer saying, I'm only an AI language model, so I can't really know, but then gives a very detailed response. And what we find over and over again is that these responses seem to really kind of help human doctors, human nurses, and others just think more clearly about the state of mind of their patients. And in fact, that can be a very practical thing. And so if the girl's name is Kim, what would you say in order to provide comfort and support? And when you prompt GPT-4 for this, you get very detailed responses. And this type of capability now is being baked into the Epic EHR system in their Epic inbox. And I think several people here have been using that. But just to have an assist, a co-pilot, as Microsoft would say in its branding, for this type of communication, to show appropriate empathy, to actually just give you reminders about what to say, has turned out to be pretty useful. I mentioned this study out of Hopkins and UCSD medicine. And here I think it was interesting that the responses were not only deemed more correct than the responses to these patient questions on social media than human doctors' responses, but actually were deemed more empathetic. And I think it's just a matter of just paying attention, as GPT-4 seems to be able to do. Continuing with that same US medical licensing exam problem, maybe I'm training to be a doctor. And so I just want GPT-4 to play act the role of the patient and let me be a doctor. And let me have a consult with this patient and have this kind of conversation. And you'll see in the responses in white from GPT-4, play acting the role of a patient, it's actually understanding something about the world model. For example, understanding that, in this situation, there would be an examination table in the exam room. And it would make sense for the patient to say, yes, I'll get up onto the exam table. And then at the end of the conversation, you can say end of play acting, and then GPT-4 will give you an assessment of how well you did in that consultation. There's tremendous interest now in several medical schools about this type of aid in training. Calculation, of course, computers are often thought of as calculation machines. And so if we're trying to do some IV drip calculation, the nice thing is that GPT-4 is capable of understanding these problems, doing the types of calculations. And since it's able to tell you step by step its reasoning, it's able to encode those things in code. So if we want an app for that kind of drip calculation, we can just simply ask for that app. And here, GPT-4 on its own decides, well, the best form of that would be as a JavaScript web app, presents the code, and then gives us short instructions on how to load that app onto our mobile phone so that we can use it in the future. And this programming capability ends up being extremely important, and I'll get back to why a little bit later. But fundamentally, some of the fundamental capabilities of GPT-4 really come from its ability to think procedurally, to be able to write code and think in terms of the procedural code that it's writing. Of course, at Microsoft, we made an acquisition of Nuance not too long ago, and so there's a tremendous interest in medical documentation. And so here's an open source, a downloaded open source transcript of a doctor-patient conversation. Indeed, you can ask GPT-4 for a medical note based on this encounter, and you can ask for it in very standardized formats, in this case, SOAP format, and then you can ask for an inclusion of appropriate billing codes. And GPT-4 does extremely well with this. And furthermore, you can have a conversation. If, for example, we might look at this and say, you know, I actually prefer to write the plan section in narrative form, not as a bunch of bullet items. And GPT-4 is able to do the rewrite. That is very quickly getting deployed out. I'm aware of a number of startup companies as well as larger companies that are integrating GPT 3.5 and GPT-4 into medical documentation products. We have been working with Epic on their integration of GPT-4, and they seem to be making very rapid progress. And then, of course, with our Nuance division into our DAX, medical documentation or clinical note-taking application. So now that's called DAX Express. For consumers, I use GPT-4 myself. And you know, one of the things that I get confused about as a consumer is I get these things in the mail. This is like a CBC lab output report. And I personally don't really know how to read it reliably. What's even more mysterious to me is when I receive explanation of benefits notices. And I have just absolutely no idea what those say. And so a great thing is just to be able to give these things to GPT-4 and just ask questions. Like, is there something I should be aware of here? Here, I'm using GPT-4 in the Bing search engine. One of the advantages of the Bing search engine is that it will give you footnotes or bibliography, things that you can click on if you want to do a deeper dive instead of asking more questions. So I wanted to get through all of that as quickly as possible. There's a lot more that you can see. We did write a paper that appears in the New England Journal of Medicine that tries to give an initial primer about what these chatbots are about, their potential uses as well as their risks and limitations. And then there's a much longer exposition that Zach and I, along with Carrie Goldberg and then Sebastian Bubeck, wrote in a book. And I know that there's been some frustrations with Amazon. They've had a back order for a while, but if you go directly to the publisher at Informit.com, I think they're shipping right away, as is Barnes & Noble. All right, so enough of that. So I wanted to get into now the gotchas with this. And there are a lot. And there's so much to worry about. There are issues that have to do with regulation. And I think there's a very significant need for regulation. There are issues with equitable access. There are many other kind of difficult questions about whether, when, and how this type of technology should be used. Too much really in the short time that we have here to talk about. So I just want to focus very briefly on three sort of fundamental things. One having to do with hallucinations. The second, the alien nature of its mathematics and logical reasoning capabilities. And then some fundamental reasoning limits. So let's start and before that, there's of course the existential question that some people, mostly in computer science, worry about, which is, does this thing understand what it's talking about? I don't take that question that seriously, but I do get that human beings, and especially computer scientists, care a lot about that question. So let's look into these. All right, about hallucination. It's very easy to get GPT-4 to hallucinate. One of the easiest ways to get GPT-4 to hallucinate is to ask it to cite its sources. And so if you do that, you ask a question like this, and you'll get a lengthy response, you'll get a bibliography with all the sources. But if you look carefully at the bibliography, you'll notice mistakes, just made up stuff. And in fact, I think a favorite thing that you'll see in social media is people look up themselves in GPT-4, and oftentimes you'll find that you had jobs that you didn't know you had before, and you've written papers that you didn't know you had written before. The thing to understand about GPT-4 is it's in a kind of a glass box. That's changing now with a plugin architecture feature, but it's in a glass box, and it does not, contrary to popular belief, it does not memorize its training data. It's distilling out of its training data kind of latent cognitive structures to try to understand what makes sense in a way in the world. So when you ask it to resurrect something from its training data, like specific papers, it's very unreliable in doing so. And this is, of course, can be a dangerous problem in medical situations. Now, one of the mitigations of this is to do something called RAG, which is Retrieval Augmented Generative AI. And the GPT-4 integration into the Bing search engine does exactly that. So if we ask the same question to the Bing search engine, the Bing search engine has instructed GPT-4, when it's given questions like this, to actually consult the World Wide Web in order to generate its sources. That doesn't eliminate all of the hallucinations, but it is far, far more reliable. And in fact, within the Bing search engine, you can pick a mode. You can have a very precise mode, which is extremely reliable, or a balanced mode, or a very creative mode, which allows it to be more free-flowing and more flamboyant. And I'll explain in a little while here why that could be important. I want to say that this idea of RAG, Retrieval Augmented Generative AI, I think is extremely important. And for any research or medical or healthcare organization that has invested in creating a database of clinical data with tools, with retrieval tools and analytics tools, I strongly urge you to give serious consideration about using GPT-4 in this RAG modality. Epic has just demonstrated this with their slicer-dicer analytics tool and their Cosmos database. And basically what that does is that turns GPT-4 into your own personal data scientist, a data scientist that can actually form the database queries, call the appropriate API and analytics endpoints, and talk to you about the topic that you're asking about. And so RAG, I think, is something that if you're thinking about what to do next, like beyond what we write in the New England Journal of Medicine paper or in the book, RAG, I think, is the next thing, especially if you are an institution or organization that has collected data. I want to say also, the RAG thing is very useful just also in your own life. This is an example from Ethan Mollick's blog. And if you haven't seen his blog, One Useful Thing, I think it's worth subscribing to. It's not a free blog, unfortunately, but I think it's very much worthwhile. But if you use the Edge web browser, you can bring up in the Edge web browser a Microsoft Word document. And here you can just write a little outline. You can see on the left just some bullet items. And then just ask Bing to fill in the rest, which includes extracting data, making data tables, and then just paste that into your Word document. And I do this routinely myself. It's a workflow that is extremely useful for writing reports, memos, papers, and so on. All right, but continuing on the hallucination issue, another thing I do here is I use GPT-4 as a aid for reading and studying research papers. And so here's a research paper from OncoTarget about a drug and its effect on tumor growth, neuroblastoma growth in Drosophila and mice. And this was a paper that one of my team members, Hoi-Fung Poon, had been studying. And so he was having this interaction with GPT-4. And so one thing you can do is just ask GPT-4 to read the paper and ask questions. So here's a question that's right out of the paper. Is Bruquitinib effective in this type of neuroblastoma? And in fact, it gives an answer. It just extracts it out of the paper and gives an answer. Whereas much more interesting, though, is when you ask questions that are not answered in the paper, or questions that may not have any known answer because the research hasn't yet been done. So we can now ask, well, would this drug be effective against an ERK negative neuroblastoma, a different kind of neuroblastoma? And here we start to see a little bit of hedging by GPT-4. It's hard to answer definitively, but it's giving some possible causal connections. And for those of you that use a tool like Microsoft's DoY causal inference tool, what we find now is that the construction of the causal graph is now completely automated by GPT-4. We can ask for a complete causal graph to be generated as the first stage of input into a causal inference tool. And I think that that has potential impact in areas like clinical trials. But continuing, Hoi-Fung Poon did not like GPT-4's answer. Hoi-Fung thought that GPT-4 was hedging too much, being too cautious. And so Hoi-Fung said, look, there are two other things. There is the fact that that ERK's downstream pathway of ALK, which is possibly relevant, and that things are ineffective against non-ALK addicted tumors. And so Hoi-Fung Poon, as a human researcher, is obviously thinking that there should not be effectiveness or impact on tumor growth for this ERK negative neuroblastoma. That's his thought process. But GPT-4 is saying, well, yes, maybe. However, there are other possibilities. And you just see this back and forth. And so some of the most interesting interactions with GPT-4, at least for me, are in this sort of research context. And the reason to show this to you is to show that this issue of hallucination is not so simple. Because what you're seeing here is technically a hallucination, but it's an informed speculation. It's a hallucination that makes sense given the cognitive latent structures that have been trained into GPT-4. And so these sorts of interactions end up being incredibly valuable, at least in my experience as a researcher. I just want to say, you can do this yourself right now in Bing. So if you use, I'm not trying to sell you on the Edge browser, but if you choose to use the Edge web browser, you can bring up a paper, just bring up a research paper, and then click in the upper right corner of your web browser, that Bing chat icon, and it'll bring up the side panel. Pick the creative mode. I find that that's the most sort of flamboyant, free-flowing version of GPT-4, and just start asking questions. Ask for the key takeaways, ask for summaries, argue with the paper, say, if you think the paper is wrong in some way, have an argument. And you can do this, and you can do this right now. And it ends up being something I do every single day because research papers are crossing my desk every single day. So hallucination is real. It's something we have to be very careful about, but it's complex. And there's something useful in its ability to engage in informed speculation. Now about math and logic errors. And here, this is an example from Zach. Zach asked this question. And it's basically providing some data and asking if there's a connection, causal connection between systolic blood pressure and salt intake. And GPT-4 correctly says, well, we can't really know. And so then Zach asked, well, how correlated is this? And GPT-4 very confidently gives an answer, that the Pearson correlation coefficient is 0.88. And luckily, Zach knows how to write his own R code, so he wrote his own R code and discovered that this is wrong. And this is something that I find particularly vexing in GPT-4. GPT-4 can be incredibly good at math and incredibly dumb at math. And it's good and bad in ways that are alien to human beings. Things that I find difficult, GPT-4 seems to find easy, or it's very reliable. And things that I find trivial, like this, GPT-4 seems to consistently struggle with. And so it's very hard to predict what goes on. And so this is another thing that is really still a subject of research. One of the mitigations for this is that you can open up a second GPT-4, give it the problem, Zach's problem, and give it the proposed solution, and then just ask, can you check this for errors? And weirdly, that second instance of GPT-4 very often reliably finds errors, spots errors, and corrects them. And so in this case, it even went so far as calculating the correct Pearson correlation coefficient in spotting and justifying its conclusion that the first GPT-4 was wrong. And if you read our book, we consistently, and we mentioned this in the journal paper as well, we consistently use a second GPT-4 just to look over the shoulders of the first GPT-4. It also is something that helps look over the shoulder of the human being as well. And so increasingly, as I've started to write code again, I use GPT-4 to look over my code just to spot errors. And it is just great to have a second set of eyes. There are, of course, reasoning limits. One of the most fundamental limits is an inability to backtrack. And so my favorite backtracking example is Sudoku. So if you think about how you solve Sudoku, you make a guess, you work out the puzzle for a while, and then you realize that that guess didn't work out, and then you have to backtrack and try a different guess. So that kind of backtracking is beyond the capabilities of this fundamentally feed-forward system. And it's important to understand that GPT-4 doesn't understand that it has that limitation. So it'll very confidently say, here's the solution. And you can say the solution is wrong, and it'll profusely apologize and try again, but keep getting it wrong. Interestingly, you can then ask GPT-4 to write a program to solve the Sudoku, and it does that perfectly. And so again, there's something very alien in the capabilities of GPT-4. All of this, of course, has completely consumed the full-time attention of, I would say, comfortably 400 people full-time across Microsoft and OpenAI, and really delving deep into explicit quantitative measures of fairness, reliability, security and privacy, inclusiveness, transparency, and accountability. And there's been just around-the-clock work on understanding these issues, measuring them, communicating them out, and mitigating them. All right, so then I do want, hopefully some time for questions. Before that, I just want to address this last question about, does this thing understand what it's talking about? And I would say that in the field, in cognitive science, in computer science, in psychology, the prevailing belief is that, of course, it doesn't. It's just a machine. And I think what has made the discussion difficult, in part, is that conclusion is oftentimes expressed with a great deal of definitiveness and oftentimes a great deal of emotion. And by some of the best minds on the planet. And so the example I have here is this op-ed that appeared in the New York Times about a month ago by Noam Chomsky and several of his colleagues. that did a deep investigation and lots of experimentation with GPT 3.5. And if you read here, the conclusion is that this thing is absolutely not thinking. It can do description and prediction, but it can't engage in causal reasoning or in counterfactual reasoning. And then it gives a simple example of just trying to explain what happens when you let go of an apple. And if you try that in GPT 3.5 or any other large language model out there, you don't get a really sensible result. But the weird thing here is give Chomsky's op-ed to GPT-4 and ask GPT-4, what do you think about this? And GPT-4 writes one of the most reasoned, well-reasoned responses. And in fact, understands, forgive me for using the word understands, picks out the central example from Chomsky's op-ed to show normative, counterfactual, and other kinds of causal reasoning for the central example of what happens when you let go of an apple. And furthermore, more careful studies, and here, if you're very interested in these sorts of issues, there is a brand new paper from Microsoft Research on causal reasoning in large language models, where we believe there is something new and different in the hierarchy of causal inference that is being exhibited by GPT-4 that we can't fully explain. That doesn't mean that it understands what it's saying, doesn't mean it's sentient, doesn't mean it is conscious, but it means that it is something new, and it's not correct to just immediately dismiss these systems as just doing word completion. There's something deeper going on. And so as scientists, even though I personally believe this thing is not thinking, it's not understanding, it's not sentient in any way, as a scientist, and if you read our book, we make this point very clearly, it is my conclusion, or our conclusion, that at this point, we do not have definitive proof that this thing is not understanding what it's saying, even though it certainly must not be. And so the thing that's very important is to keep an open mind about this. Now, this, I don't think matters at all for healthcare and medicine. It matters a lot to computer scientists or to linguists like Chomsky. But for those of you that are interested in this, this paper, I think, can be of great use. All right, so let me just finish up here. This has been a kind of a very intense period since late last summer. And then when we released, or when OpenAI released ChatGPT in November, it caught us completely by surprise with just to see the world kind of embracing and being captivated by this. And in fact, outside of China, it's the most successful product launch in human history. It just has gone way beyond all expectations. And in that first 72 hours of ChatGPT's release, we were made aware at Microsoft that people were using ChatGPT in clinical situations. And so that created, in my mind, a sense of urgency. It's extremely important that the medical community, especially the kinds of people that are in this room right now, get up to speed with this and do everything they can to take assertive control over the fundamental questions of whether, when, and how this kind of technology should be used, with an understanding that GPT-4 is not the technology. It's the next 15 versions of this type of AI that are really going to make the difference in human health. And so, as a society, we have kind of three choices fundamentally to make. One is we can decide that this is all too dangerous and that we need to shut it down and restrict it. And for medicine, maybe it just should not be used in clinical decision-making at all. That's one choice. Another choice is that we can just be willy-nilly and just be thoughtless about it, and it's just Wild West. Just give into it. But the third choice is to try to understand how best human beings and AI can work together to accomplish things that neither can do on their own. And so, basically I'm here to beg you all to think hard about that third choice and then take personal steps to embrace that. So with that, thank you very much.
All right. Thank you, Peter. That was great. I recognize authority when I see it. I see the editor-in-chief of New England Journal of Medicine at the mic, and I see that there are no questions online yet. If there are questions online, please post them, and Joe Romano will.
Zach,
Yes?
you need to speak into a microphone. No one can hear you online.
I'll repeat that, Zach. If you have online questions, please post them online. Otherwise, we can't see them. Is that fair?
It's great to have the editor-in-chief of the New England Journal of Medicine do something that I could have done also, so that's good.
Peter, thank you. It's a fascinating area. I just a technical question. You have said many times in the past that it's really important to train on general knowledge, and that gives you something very, very different kinds of answers and better quality answers in general than training on specific knowledge. How about the hybrid model where you train on general knowledge and then add in, and I think you kind of referred to this in the talk, add in health-specific knowledge or financial-specific knowledge or something? How technically available is that, and how much better is it?
Right. So it's obviously a sensible thing to do, but I think my suspicion, which is shared by others at Microsoft and I believe at OpenAI, is that specializing too soon impedes the acquisition of the kind of general cognitive intelligence that you would need to be able to steer and align the system. So I don't want to anthropomorphize things too much, and so people roll their eyes, but I don't know how else to talk about this. But you can be in danger of creating an autistic savant if you specialize too soon. That's the growing suspicion. So now the question is, does that matter for the kinds of applications you're thinking about? So if you want like a control and awareness of ethical issues, of a hallucination and so on, the program that OpenAI and Microsoft have been on has really been to achieve the general cognitive intelligence so that you and it can reason about those things successfully, and that it can be steered and aligned with human values and avoidance of disastrous mistakes and so on. So there are plenty of applications of machine learning. We heard tons of them this morning in this conference where maybe that doesn't matter. And so having a very narrowly specialized and very fine-tuned model might be okay. But if you're talking about the more kind of general, like giving every nurse and doctor a co-pilot with them, I personally would be deeply suspicious and maybe somewhat scared about going for that specialization too soon. And so this is not settled computer science by any means. And I think it's good that other research groups, for example, the team at Google, are exploring doing specialization early. I would say in our experience, for example, Hoi-Fung Poon's work on BioGPT at Microsoft Research showed exceptionally good performance on its understanding of biomed papers, but was just unsteerable, uncontrollable, unalignable. And so we've depending on the kinds of applications, and we were looking at it as an application that would support molecular tumor boards, just too dangerous. So this is just a big thing for us to understand, but I would say for our part, we are going for general cognitive intelligence to get to the point where you can actually reason successfully about this issue with the system, if that makes sense.
Hi, Peter. Thank you. This is awesome.
Thank you.
Oh, I'm Michael Patton. I'm an MD PhD student at UAB. And I was curious about ChatGPT's ability to provide provenance, citations, and sources with a response. Like if there's any progress on this, notice that if you ask a question, then ask for citations, you'll get citations back. And some of them are real and some of them aren't. DOIs can be hallucinated. So what's the status of that question and the progress for the future models?
Yeah, so at the risk of sounding like I'm selling Microsoft products, use Bing. And so if you use Bing in the precise mode, it'll be very reliable, but a little conservative because it will really rely on web sources to get all of those citations. But it's a very, we find that it's the use of the retrieval augmented generative AI ends up addressing most, but not all, of that issue. In the cases where GPT-4 is not hallucinating, like it just happens to get the citation right, a bit of a mysterious question is, how did it actually come up with that? Because it's fundamentally not really memorizing its training data, and so it's able to sometimes synthesize correct citations, which actually, just from the computer science perspective, is a little bit surprising. My own guidance is to use a RAG-based approach, and right now the best one for that kind of question would be Bing. Yep.
Hello, name's Nicholas from UNSW, Australia. The question I'd like to ask is, today you mentioned 3 different kind of applications in the medical and also clinical domain. One of them is on knowledge retrieval, the other one is document summarization, and the third one is basically about causal inference. The thing about this is that if we think about causal inference and we think about what GPT and its core is, it's really going back to the 2017 paper, attention is all you need. It's really a large-scale language model that's based on attention mechanisms. So like the 2017 paper and also some other papers that predates it, is it not possible that we actually use attention mechanism to highlight what is happening and also use this as a way to enforce causality and also to make us have more confidence in terms of what the model is actually predicting or summarizing?
Yeah, I think it's a really, first off, what you just expressed is a source of deep intellectual frustration for me. And, if you do end up going through the process of reading the book, I spend both chapters 3 and 6 sort of venting my frustration about this, because if you read that 2017 paper and think about it carefully, some of the examples, for example, in our most recent MSR paper on causal inference, it's just hard to reconcile the outputs of GPT-4 against a deep understanding of attention. And so I think you're saying 2 important things. One is if we just focus on what attention is doing, can we come up with some mechanistic explanation for these outputs? I think it's a very interesting idea, and I think that's worth thinking about. And then the other is, does that also give us some insight into what some limitations might be? One of the interesting things about that causal inference paper is it does seem to indicate that the normal hierarchy of causal inference modes, which really goes back to Judea Pearl's work, it does seem like it doesn't fit in that existing hierarchy. And so another interesting research thing to do if you're a computer scientist is to think about rewriting or revising that hierarchy. And I think in order to do that successfully, you would need to do exactly what you're suggesting. Yep. Thanks. Yep.
Last question. Dave.
Do you want to go there?
I'm here, by the way, all the way through to Friday, and so, yeah.
All right. So Gabriel Bratt, surgeon at Beth Israel and assistant professor at Harvard Medical School. GPT-4, it's very clear that its theory of mind is not equivalent to the theory of mind that a clinician has.
Yes.
And so, as you said, things that are very easy for us to do or maybe very hard for ChatGPT, and things that we find extremely difficult seem to be very easy for this algorithm to answer. And so I was curious as to the way that you've been thinking about essentially not to anthropomorphize as well, but essentially to dissect this brain. You know, we can talk about looking at different elements of this process, but I wanted you to talk a little bit more about the process of dissecting down to what are the things that are causing essentially these sparks of AGI to actually exist, and how you're actually going about, given that other groups don't have necessarily access to what's going to the model at OpenAI, how you're thinking about essentially dissecting the brain of GPT-4.
Yeah. First off, just a clarification, at Microsoft Research, we do not have access to the model weights. We do not have access to the training pipeline. Microsoft and OpenAI are two separate companies, and we actually compete against each other for example, for enterprise customers. But we also do try to help each other. The research that we do at Microsoft Research is published openly, and it feeds directly into what OpenAI does. But OpenAI also draws in ideas from really all over the place. So we do gain more and more of an understanding of what this model does. Already in the Sparks paper, we're able to identify certain limitations and certain ideas that affect, for example, how you would prompt the system. And furthermore, as research is going on, we're seeing not only out of Microsoft Research, but out of other places, a deeper and deeper kind of explication of some of the limits and some of the characteristics of the system. When we translate that into applications in, let's say, healthcare delivery, I think what has to happen is that we somehow have to have some sort of cookbook of best practices to understand exactly, when and where you need to be careful, exactly when and where you need this to make sense. The National Academy of Medicine has sort of codified that. They want to have a process that involves the development of a code of conduct around this. And so I think for this to be successful, several things have to happen as quickly as possible. One is that the medical community has to get very, very much up to speed. Computer science community has to keep pumping out more and more fundamental knowledge and sharing it, just like we're doing here. But then at the same time, I think medical community and organizations like the NAM, AMA, and others have to start trickling down to societies, to medical schools, those sorts of best practices and those kinds of cookbooks. That's the state that we're in right at the moment. So now, a question that everyone always asks is sort of the Tesla self-driving car question. What happens when we are in a world where we're using AI in life or death situations? Maybe it's more reliable than humans by some objective measure, maybe dramatically better, but it still makes mistakes that end up harming people. And so for that question, which is really a very, very difficult one, again, I'm urging the medical community to try to confront that question very directly, try to take ownership of it, and then provide the framework to regulators in the US, UK, and Europe especially, on the regulatory framework that provides the guardrails on that. So that's the best that we have today. Will we know more in a year, 2 years, 3 years? I suspect we will, because a lot of very, very smart people are thinking very hard about these things. But at the moment, this is the best that we have. And that does not mean, though, that the medical community can just sit and wait for this technology to evolve. By this time next year, it's very likely that there'll be a much more powerful, much more capable model available. A year after that, even more capable. And so the thought process really has to start now. Good. Thank you all.